Hello folks, we're continuing this some special formulae and then we are coming to the problem number 7 now. Problem number 7 is not as simple as the previous problem. Not that it's very complicated, but then there are two steps. So you have to do it like that. We can see that there is x minus 1 in the numerator. So we'll separate this and make it two separate terms and then work with that. So this is as good as writing integral of x over x squared minus 1 dx and 1 over integral of x squared minus 1 dx. So we are separating, this is one term, this is the other term. So that it's better to work like that. And here, this we can apply some formula and get, and here we'll make a substitution. So here, let's call u as x squared. So like that, when you take the derivative, du over dx is 2x. Dx we can take on the other side. Since you require only x dx there, it is du over 2. So now let's get both the integrals, and for this we will be using the formula integral of dx over root of x squared minus a squared, and that has the integral log modulus x plus root of x squared minus a squared plus c. So let's right away apply all this. So your first part of the integral is going to be x dx, as we got it as du over 2, and this is going to be x squared. So actually we could have taken x squared minus 1. Now what was the harm in taking x squared minus 1? We could have taken it, so that we'll just get root u. And okay, and then here, so when we apply the formula, it's going to be log x plus root of x squared minus 1. This is done. You've got the answer. Here we'll have to do a little bit of work. So u raised to minus half, we know, is u raised to minus half plus 1. So that's going to be half over half. So 2 root u minus, that can cancel, log x plus root of x squared minus 1 plus c. So net effect, your answer is root of x squared minus 1 minus log modulus x plus root of x squared minus 1 plus c. So it's timely detecting of that matter and then doing it. Yeah, so then we can come quickly to the 8th problem and see what it says. The 8th problem says that it is x squared dx over root of x raised to 6 plus a raised to 6. We've been always taming ourselves with the idea that we should be having a square so that we can apply this formula. So we are going to keep ourselves to that. X squared dx is as good as writing x cube whole squared plus a cube the whole square. So if you're okay working with a cube, maybe it's okay, but otherwise if you feel that a cube every time to write, maybe it's confusing, so let's call b as a cube. So let's make two substitutions here, u as x cube and b as a cube. Now b is not going to contribute, it's a number, so it's not going to contribute it doesn't create any problem, but here there will be a derivative du over dx is 3x squared. Since we require only x squared, so it's going to be du over 3, which is x squared dx. Like that, your integral I becomes du over 3. That 3 can come out, and what happens? Denominator is x cube, which is it is u squared. A x cube is u, so u squared, and a cube is b, so it's just b squared. So now you're of the type integral root of x squared plus a squared. That's very easy, isn't it? We know that the integral is log x plus root of x squared plus a squared plus c. So let's make the substitution. Log modulus x, which x plus root of x squared plus a squared plus c. So let's get it reverted back. So it is log x cube plus x raised to 6 plus a raised to 6 plus c. That's all. Yeah. I hope that's fine. So we can go to the 9th problem, which says that it is integral of dx over sec squared x And then is there a root or there's no root? There is a root. Tan squared x plus 4. So it's very, very glaring that there is a tan in the denominator, there is a 6 squared in the numerator. So it's a but natural choice that you're going to make u as tan x. So that will make your work really, really simple. So let u be tan x. We know du over dx is going to be 6 squared x. So 6 squared x dx, which makes our I as du in the numerator, denominator u squared, and 4 can be written as 2 squared, so that we are in the integral dx over x squared plus a squared, which is root of x squared plus a squared. So that's going to be log x plus root of a squared plus a squared. Yeah, we don't have any coefficient. Yeah, so let's make this substitution now. Log u plus root of u squared plus 2 squared plus c. When we revert back, it will be log u for us is tan x. And this, as I told you, is your given function. So that is tan squared x plus 4. You can write it in any given form. You know, all these converted forms, they're equivalent and they're fine. That's it. That's for that problem number 9. And problem number 10, we may not be able to do. Why? Because from here on comes that concept of completing squares. So that maybe we will keep it for the next segment, and from there we will do completing squares. That should be all for today. With more videos, maybe we can come in the next session. So thanks, and please spread a word amongst your friends. See that the channel is popular amongst everybody, and we are there everywhere. Thank you.